In Beijing, engineers at the Bird's Nest are preparing to lift the stadium's mighty columns. These are massive chunks of steel, and they need to proceed with the utmost caution.
There's been documented cases of people lifting too much weight on a crane, and the crane can collapse.
Miller Park Stadium, Milwaukee, USA, 1999. Big Blue was lifting steel roof sections. The sky looked blue and cloudless, but a strong 42-kilometer-per-hour breeze was to prove deadly. Just as it was hoisting a 450-ton section over the stadium roof, Big Blue got into trouble. Three iron workers tragically lost their lives that day. And the Milwaukee collapse remains a poignant reminder of what can go wrong. At the Bird's Nest, they're fully aware of the danger. First, the lower column sections are hoisted into position. The higher sections are lighter, but the dangers increase as loads are lifted higher and further from the base of the crane. Most treacherous of all are the upper or elbow sections of the columns. But by October 2005, the first column is successfully installed. It takes several months to get the remaining 23 columns locked in place. They've completed the first critical stage well within schedule, and they've done it safely. Then, one by one, the crisscross beams are hoisted up and carefully moved into position. It's time to get welding.
The special steel material makes it very hard for welding. The material is very strong, but it has a rather low weldability. Welders need to go through training to be able to do welding work with such material.
It's a painstaking, difficult process. There are hundreds of openings to be welded on hundreds of separate pieces of steel. Workers hover precariously 70 meters above the ground to reach the more inaccessible welds. Some of the critical joints need to be welded numerous times to make them strong enough.
All the bits are not only very complicated and very strange shape, they've also got to be constructed and assembled to very high precision levels.
This is how it will buckle the looking.
Arab structural engineer Michael Kwok knows they've got a problem. It's all to do with the extreme temperature swings that define Beijing's climate.
We were very concerned. Beijing can be as cold as minus 27 degrees and can be as hot as 40 degrees.
Steel expands and contracts as it heats up and cools down. It's a phenomenon known as thermal expansion, and it's bad news for engineers.
The structure will have to be able to expand and contract under such a condition, and there will be a lot of stresses.
The longest steel beams will experience the greatest changes in length. If they weld the beams together when the temperature is too high, the welds could crack and pull apart as the structure cools and contracts in colder weather. The Bird's Nest could literally rip itself to pieces. Welding key joints is possible only when temperatures hit 15 or 16 degrees. This means that welders face the challenge of working in the dark.
Some of these connections will have to be made on the nights because summer in Beijing is very hot. So the only time you can actually be falling into that range of temperature is at night.
After months of welding by night, each strategic weld must be carefully tested with ultrasonic and magnetic particle scanning systems.
What we're looking for is for any flaws that have occurred within the weld itself, within the body of the weld or within the parent material that might potentially weaken that joint.
All key welds must pass this stage of approval, or the bird's nest safety cannot be assured. Inside the bowl of the stadium, towering steel girders are now being erected. They are the temporary supporting structures that will hold up the roof until it's completed. From outside the stadium, the bird's nest is now starting to take on its distinctive form. Reaction among the citizens of Beijing and the world's press is sensational. The stadium is lauded by the architecture critics and adored by the public. It's already becoming a city-defining landmark.
Once the building started to take shape, people could understand and could see the vision. Instead of it being a model or a drawing, it was actually built. It's garnered a lot of interest and a lot of pride on the part of Chinese.
It's hoped that such a spectacular building will inspire some truly great sporting performances. The Chinese team took second place in the 2004 Athens Olympics, and they're aiming to improve on that record on home soil.
I believe the competition between China and the US teams will be a white-hot tug-of-war. We believe the Chinese competitors will perform even better, surrounded by cheering and chanting from home.
Long before the sports teams are put to the test, the engineering team of the National Stadium faces its own ultimate challenge. Until now, the stadium's 11,200-ton roof has been resting on support columns. But now it's complete. The time has come to remove the giant props. It's the absolute climax of the construction process. For the first time, the stadium will have to stand on its own feet. Eileen Huang and her company will be tackling this daunting engineering mission.
We were all very nervous when we first took the job to remove the supporting columns at the bird's nest. Such a project had never been done anywhere else in the world before.
Only once the full weight of the roof is resting on the columns will they know whether the bird's nest has been properly built. Their plan: to physically lift up the entire 11,200-ton roof, then cut away the supporting props. Only then will they be able to lower the roof and see if the building is self-supporting. It's a mammoth undertaking and a complicated process.
The key technology in the project was to control pressure at different points simultaneously.
They need to lift at 176 points simultaneously, or the roof could sag unevenly and crack apart. This requires 176 jacks, each of which must be precision controlled. Wang's company has developed large capacity oil cylinders. These cylinders can lift over 300 tons each and are accurate to within a millimeter. With the technology in place, there's no time to waste. The eyes of the world are upon the bird's nest for this crucial and historic moment. A team of engineers and construction workers arrive on site, ready for the mighty task ahead of them. First, they install the 176 oil pump cylinders. Each one is positioned at a key pressure point below the roof.
Our oil cylinders replaced the supporting columns, and the pressure from the main structure was transferred to the cylinders.
They can now activate the cylinders and slowly begin to raise the structure. The whole process is monitored from a computerized control center.
Each cylinder was specifically programmed at the 176 pressure points. Each specified the range of the cylinder's extension and how much pressure it was supposed to support.
If the lift is uneven and it sags by more than 290 millimeters, they'll face certain disaster.